In this video, we're going to find the antiderivative of e to the 2t cosine of e to the t dt. So we have a product. Had this just been e to the t, it would have been a straightforward u substitution. Substitution is going to help us make this thing easier though, because what we can do is we can rewrite this integral as e to the t times e to the t cosine of e to the t dt. Now, it may not be obvious why that's helpful just yet, but we're going to use a u substitution, but then an integration by parts. So I am going to use something other than u. I'm actually going to use x for my substitution, and I'm going to let it be e to the t, and then my dx is very straightforward. It's e to the t dt. Now, first instinct may be to plug in x for this one, and this one, but then we don't have enough to sub out our dt. So what I'm going to do is, before I make any substitutions, I'm going to just rearrange the order of my product. Not a necessary step, but I think it makes it more obvious what we need to do. This is exactly our dx. Now, the e to the t is x, so we end up with x cosine of x, and then this part here is just dx. Now we have something we can do with integration by parts, and we know this, and you should know now by this form, that's going to be your u, the trig function is going to be your dv. So u equals x, dv equals cosine x dx. That makes our du just a simple dx, and our v is just sine x. So putting this together in our integration by parts, we have uv, so x sine x minus the integral of v du, sine of x dx. Once again, a basic antiderivative. So we have x sine x minus, now the antiderivative of sine is a negative cosine of x plus c. So we're going to take care of these signs here in a second. Also, remember, our original problem started in terms of t. We want to end in terms of t, so we do need to substitute back using the fact that x equals e to the t. So all those x's need to become e to the t's. So we have e to the t sine of e to the t. Again, this will become a plus because of the minus negative. Cosine of e to the t plus c, and there is our antiderivative.